It's a shame to get rid of a car in this way at the end of its life, because it contains quite a large amount of valuable raw materials worth regaining. Up to now, around 80% of a car is recovered. The rest ends up at incineration plants or on landfill sites. The current European End-of-Life Vehicle Directive prescribes that from 2006, at least 85% of a car has to be recovered, and from 2015, this figure will be at least 95%. Just 5% may then be disposed. The aim of the measures is to maintain the considerable raw material potential of an end-of-life vehicle in the economic cycle. How can the raw materials from a car be regained? It needs to be done in a way that allows part of the materials and energy invested into production to be recovered economically. At first, some manual activities have to be carried out. First, the wheels have to be removed. Lead balancing weights, tires and rims are separated. Fuel and other operating fluids are pumped out. The airbags are neutralized by deployment. Batteries and catalytic converters are removed separately and sent for material recycling. The removal and storage of other components requires a large amount of manual labor and is carried out only if the parts are in good condition and if they are demanded as spare parts. The remanufacturing of engines is also only economically viable if the resale price is good. Often it is economically more attractive to also remove the non-directly reusable engines and gearboxes and then shred them separately. The ferrous material recovered out of this coarse scrap is sent straight to the steelworks as a feed for the production of high-grade steel. The rest of the car is simply pressed together for transportation, including plastics, glass, insulating mats, seats, and other parts. Being a valuable raw material reservoir, the end-of-life vehicles are no longer just scrap iron. Placed in storage, they are waiting for further processing and end up in the shredder that breaks them into small pieces. New technical developments in material separation, like the Volkswagen Seacon process, allow extensive sorting of many different materials. The recycling of almost 100% of the iron and steel is state-of-the-art. However, plastic fractions, glass and sand fractions, as well as fibers and filling materials, can now also be sorted out from the waste. Labor-intensive manual dismantling activities for recovery of these materials become obsolete. The following examples illustrate the economic value of end-of-life vehicle-derived raw materials. Shredder granulate, a fraction that is essentially made up of shredded plastics and rubber. Previously, a hardly reusable material sent to landfills, shredder granulate is now a valuable feed for steel production, where it is used as a reducing agent. Another material with interesting properties, shredder fluff, a fraction composed of textiles, foams and fiber mats. This material used to be disposed as well, until it was discovered that shredder fluff is an excellent draining agent in the dewatering process of sewage sludge. Shredder sand, a fraction made up of glass, rust, non-ferrous metals and some impurities, is now a potential resource, for example as a metal carrier and slag building material in copper metallurgy. The selected examples show that considerably more can be recovered from end-of-life vehicles than previously assumed. The use of modern technology, combined with consistent coordination of material flows, reduces the costs for end-of-life vehicle treatment considerably. New mechanical separation technologies and intelligent use of the derived fractions have the potential to give waste the value it deserves. It is the raw material of the future.